Okay, kiddos, so this is going to be your Unit 3, Day 7 video, and in this video, we're going to talk about the law of sines. We're not going to dwell too much into where it comes from. It's just something that arises as a pattern. So on the do now that you did earlier, you saw that when we took the sine of the angle A and divided it by A, right? So if we're using this particular problem that we've got here from the do now, okay, you saw that if we did sine of A over A, well, that was sine of, let's see, that would be this guy here, pi over 3, or sine of 60, right, over 10. And that gave us approximately 0.09 when we threw that into the calculator. Okay, then you did the same thing with angle B and side B, right? You took the sine of angle B, so angle B was this pi over 4, aka 45 degrees. So sine of 45 degrees is to 8.16. Okay, so from that, when you threw that in the calculator, you also got approximately 0.09. Then you did the same thing with angle C and its opposite side. Okay, so the sine of 5 pi over 12, or the sine of, the sine of, brain fart, that was 75. I do some quick maths in my head. Okay, and when you threw that into the calculator, well, guess what that gave you? It gave you pretty much the exact same thing, right? And if you remember, every single time you threw one of these into the calculator gave you something really close to this point, well, there was a zero there, 0.0866, right? Which all of them round up to the nearest hundredth is 0.09. Okay, so perfect world, if we had the perfect angle, the perfect side length and everything, this would easily have been true, right? And it was true, obviously. What you did was you proved the law of sines. Okay, so if I've got a triangle whose vertices are A, B, C, and the opposite sides are also A, B, and C, right? It just so happens that the sine of all three of these angles relative to their opposite sides, they're all equal, or they're all proportionate rather. Okay, and that is exactly what you observed in the do now. Okay, so let's look at some examples, moving on to EQ2. So how or when can we use the law of sines? So let's talk about how we use the law of sines. So we can use that proportionality to our advantage, right? We can say that because of this, we can use it to find missing sides and missing angles on triangles that are not right triangles. Okay, so this is going to be the first instance that we have of using trig on non-right triangles. Okay, so let's try it here. Okay, so we're trying to find this missing side C, and we have two missing angles here. Right, so we can use this, the law of sines, to our advantage here. Okay, now, it takes some practice to get used to how to set this up. Okay, so let's go ahead and try to find theta 1, for example. Right, so the sine of theta 1 is to its opposite side, which is C in this case, as the sine of 30 is to 12. Well, we've got a little bit of a problem here. How many unknowns do you count? Well, this is unknown and this is unknown. So we have two unknowns, right? So that's pretty much impossible for us to solve. Okay, so we need to try setting this up maybe a little bit different. Let's see if I can erase that without, there we go. So let's try setting it up a different way. Let me use a different color here. What would be a good color? I guess none of these. I'll use green. Okay, so let's try and find theta 2 instead. So the sine of theta 2 is to its opposite side, as the sine of 30 is to its opposite side. Okay, and there we see we have it set up with only one unknown, which is good for us, right? Because that means all we have to do is cross multiply. And in this case, we don't even have to do that. If we work smart, we can just multiply by 10 on both sides. And we end up with the sine of theta 2 is equal to 10 times the sine of 30 all over 12. Okay, and we can go ahead and reduce a little bit. So that would be 5 sine 30 over 12 equals sine of theta 2. Take the arc sine of both sides, and we get that theta 2 is equal to the arc sine of 5 sine 30 over 12. Whoa, why did I not reduce? That should be a 6. I said it with my brain. I don't know if I said it out loud, though. Okay, so when we throw this into the calculator, right, so we're going to say sine of 30. And of course, we get 1/2. And we multiply by 5. And of course, we're going to get 2.5. So we really have the arc sine of 2.5 over 6. So we go ahead and throw that into the calculator. So 2.5 over 6. We get approximately 0.42. And we take the arc sine of that. And we get 24.62 degrees. Right? So pretty straightforward here how this works. We'll go ahead and just write this down. So this is approximately 24.62 degrees. Right? And if that guy is 24.62 degrees, okay, and this guy here is 30, we can just add those two together and subtract from 180 to find our missing theta 1. So 24.62, I'm just going to add that to the 30 minus 180. We know that's not a negative, 125.38 degrees. Right? So now we have all the information we need to finally find that missing side C on this triangle. Let's go ahead and do that. Okay, so sine of 125.38 is to our missing C, as we'll go ahead and use the 30 and the 12 again. Okay, cross multiply, C times sine 30 equals 12 sine of 125.38 degrees. Okay, divide on both sides by sine of 30, and we get that C is equal to 12 times the sine of 125.38 degrees divided by the sine of 30. And if we go ahead and simplify a little bit, so we're going to have 12 sine of 125.38, and we already know the sine of 30 is 1/2, so I'm just going to put a 0.5 there. So start throwing things into the calculator. So sine of 125.38, that gives me 0.82 thereabout. Multiply that by 12, and we get 9.783. And we're going to divide that by 0.5, which is the same thing as multiplying by 2. And we get that C is approximately 19.57 in length. Okay, so this side here, we found it using the proportionality that we call the law of sines. Okay, and we can use that to find missing angles, as you saw, or missing sides. Either way. Okay, so let's look at another example. And I'm going to erase some of this just so that there's not so much clutter here on the screen. And I'll use pink this time. I don't know why I didn't use that the first time. That's a color that's not on here. Anyway, so let's go ahead and convert these angles. So I'm looking here at triangle B now. Let's go ahead and convert these angles to degrees so our little human brains can wrap our heads around this better. So obviously this pi over 6 is 30 degrees. This 3 pi over 5, well, that would be, so what we would do there And let me just review how that's going to work. So degrees are equal to 180 times theta all over pi, right? So 180 times theta all over pi, okay? The pi's are going to cancel. We're going to end up with 180 times 3/5. Okay, so if you have a crappy phone calculator you're using, you're just going to say 180 times 3, which gives you 540, and then you divide that by 5. Okay, so this angle here is 108, right? Or over time, you'll start to memorize 1 pi over 5 instead of 3 pi over 5. 1 pi over 5, or pi over 5, is 36 degrees, and you can just multiply that by 3, which still gives you the 108. Okay, so let's go ahead and use the law of sines here to find our two missing sides this time. Okay, so we're going to go ahead and say the sine of 108 is to our missing c as the sine of 30 is to a. Well, why would this not work? How many unknowns do I have? 1, 2. So that's not going to work. We're going to have to try a different setup. So let's continue trying to find the right missing side, but let's go ahead and calculate what this missing angle is, right? So we've got 30 degrees, 108 degrees. Let's just subtract that from 180. We get that this guy is 42 degrees. Okay, so now we're good to go. So I'm going to use this known angle. So I'm going to say sine of 42 with its opposite side, which is known. Now we only have one unknown, and we're good to go. Cross multiply, 11 sine of 108 equals c times sine of 42. Divide by sine 42 on both sides, and we get that c is equal to 11 sine 108 divided by the sine of 42. And now let's start plugging into the calculator. So the sine of 108, we get about 0.95, multiply that by 11, we get 10.461, about. Okay, and that is over the sine of 42. And we get about 0.669. Okay, and then we go ahead and simplify that rational expression. And we get side C is approximately 15.63 in length. Okay, so side C, approximately 15.63. Okay, so now let's find the other missing side, since we know all three angles now, and we know all the sides but one. Let's find that last missing guy, side A. So I'm going to say sine of 30 is to its opposite side, which is A, as sine of 108, why not, is to 15.63 that we just found. Okay? So, same idea as before, cross multiply. 15.63 times the sine of 30 equals A times the sine of 108. Divide by the sine of 108 on both sides, we get that A is equal to 15.63 times the sine of 30. All of that over the sine of 108. Okay, so sine of 30, we know that's 0.5, or half. That times 15.63, we get 7.815. And that's going to be over the sine of 108. And that is approximately 0.951. Go ahead and simplify that with the calculator. So 7.815 divided by the 0.951, we get about 8.22. So A is approximately 8.22 in length. Okay, so using the law of sines is really not that bad. Really not that bad. Now, we still haven't completely answered how or when, so we know how, but we haven't answered the when part. When do we use the law of sines? Okay, obviously we use it when it's not a right triangle, right? And let's look at an example when we wouldn't be able to, right? So this triangle C right here is going to be our example where we would not be able to use the law of sines, and I'll show you why here in a second. Let me erase and give myself some room. Okay, so triangle C would not be a case where we use the law of sines because, well, there's no way to set it up with there being only one single unknown, right? So if I do the sine of 115, I know this angle here, right? But I don't know the other two, and that's not enough information to calculate theta 1 or 2, right? So if I do sine of 115 is to A, which is unknown, as sine of theta 2, so there's two unknowns already, is to 52, so that's not going to work. And then on the flip side, if I do sine of unknown theta 1, well, there's a second unknown already, is to 16. So no matter how I set it up, so if I go here and here, I've got 1, 2 unknowns. If I go here and here, same thing, 1, 2 unknowns. And if I go here and here, 1, 2 unknowns. Okay, so let's talk about the pattern there, right? So the pattern there is that we can use the law of sines in two cases, okay? If we're given two sides with a non-included, and I'll show you what that means in a second, angle. Okay, so this first example, triangle A, we had two known sides, right? And we also knew an angle. This angle was not enclosed. It was not enclosed by our known sides, okay? So this 30-degree angle was not here where it's enclosed by the 10 and the 12. Okay? That's what we mean by non-included. It's not enclosed. Okay? Over here, we had, and I don't remember what this side was supposed to be because I erased it because I'm stupid. Let me pause the video and look. Yeah, it turns out it doesn't even matter because this side was unknown anyway. This was A. It was just unknown. Okay. Anyway, so the other case that we can use the law of sines is if we're given two angles with a non-included side. Okay, so we've got two angles are known, and these two angles do not encompass, well, they do, but we're able to figure this out. Okay, so we've got three known angles in this case. I should say at least two angles with a non-included side. So this 11, right? I can use this guy, and I would not be enclosing the 11 with those two angles, or including, right? Now, the example where we couldn't use it, well, what did we have? We had two sides, two known sides, and we did have an included angle. Okay, so that's no bueno. That means we aren't going to be able to use the law of sines, and you saw it there. Okay, so let's do a little more practice. Let's do a few more examples. Okay, so number one, let's use the law of sines to find this missing x, missing y, and that missing theta. Of course, the missing theta, we can just use common sense. Okay, so pi over 4, We should have this memorized by now. Pi over 4 is 45 degrees. Pi over 9, should have that memorized, is 20 degrees by now. Okay, you're going to see a lot of these over and over again. And 20 and 45, that's 65, taken from 180. That leaves us with just 115. So this guy is 115 degrees. So now we just need to find our two missing sides. Okay, and you'll see we've got at least two angles and a side that's not included, or rather it doesn't have to be included. Okay, so the sine of 20 is to 10 as the sine of, let's find x first. So the sine of 115 is to its opposite side, x. Just cross multiply. I'm going to try and write tiny so I have plenty of room for the other examples. So cross multiply, so we've got x times sine of 20 is equal to 10 times the sine of 115. Divide by sine of 20 on both sides. And we start throwing things into the calculator. So sine of 115. That gives me 0.91 thereabout. Multiply that by 10. And we get 9.063 is what we'll call it. Computer's being laggy. Sine of pi over 9 or sine of 20, that's going to give me 0.342. And we go ahead and do that division, that quotient in the calculator. So the 9.063 divided by the 0.342, we get 26.50 thereabouts. Okay, so now let's find side y. So we can still use the 20-degree angle in the 10 because why not? So sine of 20 is to 10 as the sine of 45 is to our missing y here. Okay, so cross multiply. We end up with y times the sine of 20 degrees is equal to 10 times the sine of pi over 4. Divide by sine of 20 on both sides, and y is equal to 10 sine 45 over sine 20. Start throwing things into the calculator. Sine 45, multiply that by 10. We get 7.071 about over sine of 20, which we already know, it's right here. I don't know why I threw it in the calculator again. 0.342. Okay, and we go ahead and divide those. 7.071 divided by 0.342, and we get approximately 20.68. Okay, so side y is approximately 20.68 in length. Okay, so all three angles were found and all three sides. Okay, let's look at number 2. Use a different color here so it doesn't get so mucked up. Okay, so I know one angle and two sides, right? The angle, however, is not included or encompassed or enclosed by our two known sides, the 30 and the 18. Okay, so I can use the law of sines. So I'm going to go ahead and convert this guy. So this is 60 degrees. And actually, no, it's not. I was supposed to change that. That should be pi over 6. Let's go ahead and change that. I just forgot to hit save. Okay, so this guy is supposed to be 30 degrees. Okay, anyway, good thing I caught that. So we know this angle, it's not enclosed, right? So we're good to use it. So we can go ahead and say sine of 30 is to its opposite side, the 18, as, let's go ahead and find theta 2. I mean, we kind of don't have a choice, right? Because if we use theta 1 first, then we're going to have another unknown, right? And we can't have two unknowns because that's impossible. So we're going to go ahead and find theta 2. Okay, so we're going to cross multiply. Actually, no, we're not. We're just going to multiply by 30 on both sides. Let's work smart, right? Okay, and then the 30 over 18, we can reduce that by 3, or actually by 6, and that's going to give me, come over here, so that's going to give me 5 sine 30 over 3. 30 divided by 6 is 5. 18 divided by 6 is 3, equals sine of theta 2. Take the arc sine of both sides. Theta 2 is equal to the arc sine of 5 sine 30 over 3. Okay, so let's start throwing things into the calculator. So sine 30, obviously that's 1/2 times 5, that's going to be 2.5. So I can go ahead and plug that in right here and just say that that's approximately 2.5. Actually, it is exactly 2.5. And then that divided by 3, and we get 0.833 repeating. And we take the arc sine of that, and you can just hit the arc sine button at that point when you get the 0.833333, and you get theta 2 is approximately 56.44 degrees. But something seems wrong, right? This angle here is acute. And theta 2 over here is obviously obtuse, right? So something's goofed, right? Well, if you remember, right, all of our trig functions always have more than one solution. So this 56.44 is what the calculator is telling us our reference angle is. Okay, so remember, trig equations always have more than one solution. So our reference angle is 56.44. So we have to go up that same amount away from 180, right? We have to go 56.44 up in the quadrant 2, where sine is positive, just like quadrant 1. Okay, so all we need to do is 180 minus that. And we get our actual answer. Okay, so 123.56. This is the answer we want for theta 2 because it's obviously obtuse. So that means it's in quadrant 2. You have to be careful about that with the law of sines. Okay, so 123.56. And now that I know 2 of the angles, I can just subtract from 180. So just add 30 minus 180, and obviously we know it's not negative. The remaining angle, theta 1, is approximately 26.44 degrees. Okay, so there's our second missing angle. Now that we know those missing angles, we can use it to find this missing side A. And that's exactly what I'm going to do. Let me erase and give myself a little bit of room here. Don't need much. So we're going to say the sine of 26.44 is to A as, we'll just use the 30 and the 18. The sine of 30 is to 18. And we're going to cross multiply and get A sine 30 equals 18 sine, and I guess I didn't give myself enough room. There we go. 18 times the sine of 26.44. Divide by sine on both sides. A equals 18 sine of 26.44 divided by the sine of 30. Go ahead and throw that in the calculator. So sine of 26.44 that gives me 0.445, excuse me, and we multiply that by 18, and we get 8.015 thereabouts. And we're going to divide that by the sine of 30, which we already know is 1/2 or 0.5. And that's what we're going to throw in the calculator. And we get approximately A is 16.03. Okay, so we found the missing sides, missing angles. Now let's work a few more examples. This last triangle down here. So what have we got? We note 1, 2 sides. Oh, we're given the angle included by the 13 and the 24. See that? So that means we cannot use the law of sines on this guy. Okay, so I think you've seen enough examples now. Okay, so we answered what is the law of sines. It's a proportional relationship between the sine of an angle and its opposite side on any triangle. They're all proportionate. And we learned how and when to use the law of sines. Okay, how? It's just cross multiplication, right? Using your calculator, using your brain. Obviously, be careful. If you have an obtuse angle, right, your calculator is probably going to give you the reference angle and not the actual quadrant 2 angle that you need, so be careful of that. Also, when do you use the law of sines? When you're given 2 sides and a non-included angle, or 2 angles and a non-included side. Okay, that's all for this lesson. Let me know if you have any questions. Otherwise, goodbye.